In this video, we study geometric progressions and how the general term in a geometric progression looks like. Look at the three sequences 1, 2, and 3. In sequence 1, you can see quite easily that from one number to the next, we multiply by 2. Therefore, the next number should be 32. For the second sequence, we can see quite easily that from one number to the next, we multiply by 2/5. And therefore, the next term should be 32 over 625. For sequence number 3, we can see that from one number to the next, the sign changes. That means we multiply by -1, and therefore the next term should be -1. For all the three sequences, each successive term can be obtained by multiplying a constant, which is called a common ratio, to the preceding term. In the first sequence, the common ratio is 2. Second sequence, the common ratio is 2/5. And for the third sequence, the common ratio is -1. Now, a number sequence that has this property is known as a geometric progression. How does a general term of a geometric progression look like? If we denote the first term in a geometric progression by A, then the next term is obtained by multiplying R to A. So next term is AR, third term is AR squared, fourth term is obtained by multiplying R to the third term, so it should be AR cubed, and so on. We can see that if we rewrite A, the first term A as AR to the power of 1 minus 1, R power 0 is 1, and AR for second term AR to be AR power 2 minus 1. Third term AR squared, we can write it as AR power 3 minus 1. Observe the relationship between the position of the term and observe the relationship between the suffix and the power, as I highlighted. Can you see that for any nth term in a geometric progression, U subscript n, when the position is n, the nth term is denoted by AR power n minus 1. Next, we proceed to examine a few sequences and we try to identify which one among them are geometric progressions. Take a look for the sequences A to E. Are you able to identify the geometric progressions? For A, we can observe that we multiply by 2 from one term to the next. So the first one is a geometric progression with common ratio 2. How about second one? For sequence B, one term to the next, we multiply by √2. Second term to the next, we multiply by √2 again. And this 2 √2 to 4, we multiply by √2 again. So B is again a GP with common ratio of √2. How about C? From 1 to the next number, yes, we multiply by 1. From 1, the second term to the next term, we multiply by 2. The next term, we have to multiply by 3 over 2. Well, we can't really see the same number being multiplied from one term to the next. So C is not a GP. In fact, C is called the Fibonacci sequence, whereby each term is obtained from the previous two terms through addition. Meaning, the number 2 here is obtained by 1 and 2 added together. 3 is obtained from 1 and 2 added to give 3. And so on. How about D? For D, from the first term to the next, we multiply by negative x over 3. From second term to the next, we multiply by negative x over 3. From third term to the fourth, we again multiply by negative x over 3. And so on. So we can see that for D, we have a GP with common ratio negative x over 3. That's when we assume that the same term is multiplied for the rest of the sequence. For E, from one term to the next, we are adding 11. So actually E is an AP, it's not a GP. For E, we have AP of common difference of 11, not a GP. In the next example, for example 5, we will examine how we can use the general term of a geometric progression. Thank you.